we had just done the question with the camper, and we were looking at this question right here. Okay, is where we left off. I put this up, but we didn't really get a chance to get very far on it. So I'll have you guys diagram that out and give it a try here to start things off, and then we'll walk through it together. Okay, just so you have the diagram in case you're stuck here. Okay, we start out with 20 meters south. Okay, then we go back 5 meters north. And then we go 8.5 meters west. Okay, I think we got the diagram done at the end of class, right? Okay, so my resultants, okay, which would represent my total displacement, is going to run from my initial position to my final position, and it's going to look like that. Okay? That line represents my total displacement. In this trip, the band ends up west and south of where it started. So what you need are the magnitude and direction of that line. All right, give you a couple more minutes. All right, in this question, how far west does the band end up from its starting position?
8.5 meters.
8.5 meters, right? The only time they go east or west is right here. So this line and this line, even though I haven't drawn them that way, are the same length. Okay, this is 8.5 meters west. How far south do they end up from their starting position? 15 meters, right? Because they went 20 meters south and then came back 5 to the north. So that means this line here is 15 meters. Now that I know those two sides, can I get the magnitude and direction of my resultant displacement? I sure can. Okay, use Pythagorean theorem here. Okay, so D is going to be the square root of 8.5 squared plus 15 squared. Sorry, I forgot to fire up my calculator. And then to get the angle, okay, theta will be the inverse tan of the opposite side, which the way I drew this triangle is the 15, divided by the adjacent side, 8.5. If you drew the triangle the other way, that's totally fine. You're just going to get the complementary angle. Mine's going to be south of west. Yours will be west of south. That's totally okay. All right, so our Pythagorean theorem calculation, 15 squared plus 8.5 squared, 17.24 meters, and then our trig calculation for the vector, inverse tan of 15 divided by 8.5, 60.46 degrees. And for me, that is south of west. Okay, and again, the way I determine that, I look at the arc I drew. It's touching west, so whatever it is going to be of west because it's measured from west, and I went south of west. Okay, everybody follow there? How many significant digits should my answer have? 2. Okay, 99% of the time, guys, the rules for significant digits are whatever the least number was that you used, that's the number of your answer. Okay, that literally, I kid you not, works 99% of the time. Okay, so this has 2, this has 2, that has 2, they all have 2. Okay, so my answer should be 17 meters at 60 degrees south of west, or if you had 30 degrees west of south, that is also. All right, all vector addition comes down to figuring out in the end, how far have they gone horizontally from where they started, and how far have they gone vertically from where they started. So you can build a right-angled triangle that contains what you're looking for as the hypotenuse. That's what you're always trying to get to with vector addition. Okay, questions on how that one worked? Okay. All right, before we do this one, let me ask you this. If I was given this vector, okay, so 25 meters at 30 degrees north of east. Okay. How could I figure out how far east and how far north I go while following that vector?
You could find the third angle.
Okay, I could find the third angle. I definitely could do that. But I could find how far east and how far north I go without it. But I could find it for sure.
You can use sine law, as you know.
Yeah, you can use, well, trigonometry. We try to avoid sine law. If you took math already and you've done sine law, good for you. We don't usually use sine law just because we're looking for an analysis of what happens, and sine law just gives you an answer. We want you to see actually what happens with the physics. So yeah, lots of people try sine law, and then if they do it wrong, I can't help them. Okay. So we would use trigonometry though, definitely, and we could use sine law if we wanted to. Okay. So what I would do here, guys, is what I'm really looking for is the horizontal part, x, and the vertical part, y. Okay? Since I know the hypotenuse and one angle, I can use trigonometry to figure out what x and y are. Okay? Which trig function would I use to find x? Cos, because x is adjacent to the angle, right? Cos is opposite, or sorry, is adjacent and hypotenuse, okay? So I would say then that the cos of 30 degrees equals the adjacent side, x, over 25. Okay, over the hypotenuse. Everybody okay with what I wrote there? Just simple trig ratio. So if I want to find x, what do I do with the 25? Right, multiply 25 over to this side, right? Because right now I'm dividing by 25. So if I went cos of 30 degrees, okay, which your calculator will put in brackets, okay, times 25, that will give me the horizontal component of this vector. It'll tell me how far this vector goes east in this case. All right. So if I punch that in, making sure my calculator is in degree mode. Okay, so cos of 30 times 25. So in this vector, or following this vector, I will end up 21.65 meters east of where I started. I'm also going to end up somewhere north of where I started as well, but this is just the east or horizontal component. So I've got that 21.65. How would I find y?
5 squared minus 21.65 squared.
Okay, I could use Pythagorean theorem. Okay, I definitely could do that now that I've got two sides, or
You can do sine 30.
right, I can go sine of 30, right? Find the opposite side using the numbers I was given. Okay, and I always say, yes, that's totally valid to use Pythagorean theorem once you have two sides, but remember, if you messed up your calculation here, that's going to be wrong too. Maybe you want to not take your chances with numbers you calculated. That's a confidence thing, it's me. Okay, but it's always a good idea. So to get y is the opposite side, so we use sine for that. Sine of 30, okay, equals opposite over hypotenuse. So if I want to find y, I do the same thing I did in the last one. I multiply the hypotenuse over to the other side. Sine of 30 times 25 equals y, and that's going to be 12.5 meters. Yes, I did just do trig in my head. I picked 30 degrees because the sine of 30 is 0.5. It's one of those things that I do. Makes me feel superior until I tell people. And then okay, everybody with me on what I did there? Okay, so all we've done here is what we call resolving into components. We've resolved our single vector into its horizontal and vertical components. It's just trigonometry, nothing you didn't learn how to do and do multiple times in math. Okay? This is the basis for how you add vectors like this together. Okay? We're going to move to a point where we're going to be solving a question like that. Okay? And it would be worded something like this. A person walks 30 meters at 40 degrees south of east, then turns and walks 12 meters at 25 degrees north of east. What is their resultant displacement? Okay? Well, if we can do this and break down any vector into its horizontal and vertical components, we can figure out what this thing looks like in total. Okay. So would that black line be my displacement? Okay. And in this question here, I end up east and south of where I started. Everybody okay with that? All right. So I'm just going to say that that's the horizontal or x component of the displacement, and this is the y. And the same is true for the other triangles. This would be x, and this would be y, and so would this. And just using the different colors so we can see them here. Now, if I could calculate purple x and red x, if I add those two numbers together, do they equal black x? Right? If I take how far east I go here and how far east I go here, that's how far east I go in total. And the same with the vertical ones. I went south for the first one, came back a little bit north in the second one. If I add those together, making south negative and north positive, that will give me my resulting y. Okay? So you do have to do, I'm not going to mince words, you have to do a lot of trigonometry. But it's always the same trigonometry. You're just finding the sides when you have the hypotenuse and an angle. It's always the same. And then putting your x's together and your y's together to get the big picture. And then from there, if you knew black x and y, you could use Pythagoras to get the hypotenuse and trig to get the vector. Okay? It seems like a lot. And I won't kid you. Those questions typically take a while, but not because there's any one part of them that's really hard, but because there's so much to do. Okay? Like to do that question there, you've got to do 5 trigonometry calculations and a Pythagorean theorem calculation. Okay? That's going to take a little while for sure. Okay? But no one step of that is any harder than what you told me for that purple triangle there that we started with. Okay? It's just those steps multiple times. Okay? So let's look at one that would be like this. Okay? I wouldn't give you one any harder than this on a unit exam. We'll do ones harder than this for sure, okay? But I wouldn't give you one any harder than this on a unit exam. Okay? So write this one down and just draw the diagram. Okay. All right, let's just kind of look at the diagram here just to get ourselves started here. So our first vector is 10.6 kilometers at 30 degrees north of west. So the way I do this in order to make sure I get at least an accurate drawing is I draw a dotted line that goes west because it told me it's 30 degrees north of west. Okay. Then I just draw a line that is 30 degrees, that might not quite be 30, but it'll do, okay, 30 degrees. This is going to be 10.6 kilometers. This will be y, and this will be x for my green triangle. How far north and how far west that helicopter flies during that part of the trip. Now, the next vector goes where? We always draw them tail to head, right? So the second vector has to go here on the head of the first one, and it's 18 kilometers south. Okay, is scale important here? Like I made sure that 18-kilometer line was much longer than the 10.6-kilometer line, okay? Because otherwise my diagram will lie to me, okay? And I'll get the math right, but my diagram will look different than my math. And what's our natural tendency? To believe your picture, because pictures are easy and math is hard, okay? And that's our natural tendency, is to go to, I must have done the math wrong. Okay? More often than not, what people do wrong is the picture, okay? And they do the math just fine. Okay, so there's the trip. Where would I draw a line that represents the total displacement of the helicopter? We always draw it from initial to final, right? Just from here, that's my initial position. That's the final position. And then I would draw a triangle for that. This would be x, or sorry, this would be y, that's vertical, and this would be x. Okay, and the angle would be this one. Why is that angle going to be my vector? Why not this one?
It's relative to the compass, right?
It is relative to the compass, yeah.
So you have to put the angle there so you can get, you can say, what's that? That's west of south.
Exactly, that is west of south. And it's the one that tells them how to get from the initial position to the final position. This angle tells them how to get to the initial position from the final position, and that's not what I want. You always want to draw the angle so that it faces the final position from the initial. The way I tell people to do it is, if you're ever not sure which angle to draw, circle your initial position, and wherever it goes through your last triangle, that's the angle you want to find. Okay? And that'll always work. Okay, so now that I've got that diagram drawn, I need to figure out how far south this thing goes in total and how far west it goes in total. Which means I need to figure out green x and green y. Would you agree? Okay, I'm going to give you a few minutes. See if you can calculate for me green x and green y. Okay, and it's a good question. Okay, do I have to draw the triangle for the resultant the way you did outside of the diagram? Absolutely not. If you want to draw it inside of the diagram, the sides are going to be the same. All that's going to be different is you're going to get south of west and I'm going to get west of south. Both of those will be right because they'll be complementary angles and they'll point the same way. Okay? I always like to draw my triangle outside of the rest because otherwise it's like overlapping stuff and it starts to boggle my whole mind. Okay, so I try and keep it outside. It's totally up to you. There's no wrong way to do that. All right, so the things we have to do if we're going to get our overall resultants, so the hypotenuse of the black triangle there, is I've got to find the x and y, or the horizontal components of all the parts of the trip. Okay, so to find green x, it is adjacent to the 30-degree angle. So green x will be the cos of 30 degrees times the hypotenuse, 10.6. All right, so that side is 9.18 kilometers. And that is west. Okay, and then for our y is opposite of the 30-degree angle, so that's going to be sine of 30 degrees times the hypotenuse, 10.6. That's going to give us 5.3 kilometers north. Okay, everybody all right with that? Now, for the 18-kilometer line, how far east or west do I go when I go 18 kilometers south? If you go due south, do you go east or west? No. That's why there's no triangle for that line. It's simply south, that's all. So the x component, the east or west amount, is 0, because you don't go east or west if you're going due south. You're just going south. That means that red y is how much? If I just go due south, I went how far south? Are you guys lost or shy? Okay. The y component's the vertical component. It's north or south. I went 18 kilometers south. What's y? I see people smiling. Are you just shy? Okay. Like, we understand that that's 18? You can nod. I have to know one way or the other, guys. Okay? Otherwise, I got to teach it different. Okay. So now, I've got all the components, all the parts of this trip, vertical and horizontal, figured out. So black X and green X are they're equal. Okay? I only go west in the first one. So all of the west part of this trip happens right here. Okay? That is the only time I went west. Okay? What we do when we're trying to calculate our resultant's x is we add the two x's together. Well, 9.18 plus 0 is 9.18. And then I always do this. I always show that that's west. I draw an arrow for that. Okay? And then for y, I know that it's south. Okay? But for this one, I've got to put these two together. One is north, one is south. So I have to subtract these, okay, or add them together and make south negative, whichever. Okay, so that's going to be 12.7, I believe, right? But I should actually get all of the numbers. Okay, oh no, it's that. It's 12.3. Okay. Now what? I'm looking for this. This is my overall displacement. I need its magnitude and its direction. Can I calculate D now? Okay. How would I calculate the magnitude of D right now?
Pythagoras theorem.
I'd use Pythagorean theorem. I have the two sides of that triangle, so I can totally use Pythagorean theorem to get D. Okay, so I'll take my 12.7 squared plus 9.18 squared, but I'll use all the decimals from my calculator for that one. So square root of, okay, that number squared plus 12.7, that is all the decimals squared. All right, so the hypotenuse there, the magnitude of my overall total displacement, is 15.67 kilometers. Can I find the angle as well? Okay, so this is just trigonometry now. Theta equals tan to the minus 1 of opposite over adjacent. So 9.18 with all the decimals divided by 12.7. So that angle is going to be 35.86 degrees. And for me, that is west of south. How many significant digits should my answer have? This number has 3 significant digits, 2 and 2. My answer should have. Okay. It can't be more accurate than my least accurate numbers. My least accurate numbers had 2 significant digits in them. All right, so my final answer then should be 16 meters at 36 degrees west of south, or at 57 degrees south of west. Sorry, not 57, 54. I can really math on this. Okay. Questions on that one? Right, does everyone kind of see the process there? Right, so we have to make sure we draw everything in there, okay, as accurately as possible. Find all of the horizontal and vertical parts, and then put them all together. Put the vertical parts together, put the horizontal parts together, and build our results. Okay, build the final piece of the puzzle. All right, I'm gonna give you a couple minutes break here, and then we'll have a look at some more. So this is just the notes for what I demonstrated to you earlier today, so we'll just kind of quickly go through them. Any vector that you're given has magnitude, so that would be the blue line A, how long it is, and direction, theta. Any vector quantity you get can be resolved into its horizontal, or x component, and vertical y component. Right, which is exactly what we did on that previous problem. We just broke down any of our angled vectors into their horizontal and vertical parts using trigonometry. Okay, so that next slide is just showing, here are the trigonometric calculations that you would do. Okay, the adjacent side is going to be calculated by taking the hypotenuse and multiplying by the cos of theta. The opposite side is going to be calculated by taking the hypotenuse and multiplying it by the sine of theta. Okay, all math stuff that you already know. If we have more than one vector, then we do that for all of the vectors. And then we simply add the x's and the y's together, keeping in mind that if they reverse on each other, one will have to be negative. Okay? So basically what it breaks down to is this, right? If I've got these two vectors, A and B, right? Each one of them goes horizontally and vertically. And if I can calculate those horizontal and vertical parts, I can put them together, as they're showing here in the second one, to get my resultants, x and y components, and then I can use Pythagorean theorem and trigonometry to get the answer for the whole big picture. All right? Everybody okay with that? Okay. All right. This one's already got the diagram drawn, which is arguably the hardest part of any vector problem. Okay, but what I'd like you to do is copy this one down, okay, diagram included, and then we'll look at, actually we're going to change one thing here. We're going to do this instead. So ignore this 70-degree angle here. Okay, and we're going to use this angle here, 30 degrees from the vertical. Let's have a look at this one. So in this question, the story goes that the object first follows vector A, which is 30 degrees to the right of the positive y-axis. Then it follows vector B, which is 35 degrees below the positive x-axis, right? Because positive is up and right in a xy plot, and left and down are negative. Everybody okay with that? All right. So those together make up the resultant, which is C. Okay. C is going to be this far to the right and this far above the starting point. Okay, that'll be the final position relative to the initial position. So if I want to find red x and red y, do I first need to find all the other x's and y's? In other words, do I need to figure out how far up and over or down and over the other two vectors go? This means yes. This means no. I gotta have some interaction from you guys, otherwise I'll just start calling on people. Okay, I don't wanna have to do that. Okay, so this is gonna be y, and this is gonna be x, okay? And then, obviously for our yellow one here, okay, this is gonna be x, and this is gonna be y. All right, so if I wanna calculate those things, let's calculate blue x first. What trig function am I gonna get to use, or use to get blue x?
Sine.
Sine. It's opposite the 30-degree angle. So we'll go sine of 30 times, okay, this side here, which was, what did I take it off there? 145. Just gonna put those numbers on there, 105. Okay. Okay, why did I put 30 in there? Nobody caught me on that one either. What should that angle be? $70 and 30 add up to 100. It's supposed to add up to 90. That's a 90-degree angle there, right? I do that all the time. I'm terrible for that. It should be 20. Okay, sine of 20 times 145. Okay, so sine of 20 times 145. All right, 49.59. I'm going to keep all those decimals in my calculator, but I'm only going to write the first two. 49.59 meters, and that's going to be positive because it's to the right. Okay. Now, in order to get y, I'm going to have to use cos, yeah, because it's adjacent to the 20-degree angle. Okay, so that side's 136.26. I'm just rounding off. I'm going to keep all those decimals in my calculator, okay? And that is also positive because it is up. Okay. All right, now I've got to do this stuff for the yellow triangle. Okay, the x component for the yellow triangle is adjacent or opposite the 35-degree angle. Adjacent, yeah, it's beside the 35-degree angle right here. So for that one, I'll use cos. 35 times 105. Okay, so 86.01 meters. That's also positive because it's in the same direction, it's to the right. Y will be the opposite, so I'll use sine for that. Sine of 35 times 105. Okay, so 60.22. Is that number positive or negative? Yeah, it's negative because it's pointing down. Okay, so compared to this y, which was up, this one is negative. All right, now I've done kind of the heavy lifting. I've figured out all of the x and y components for this question. What do I do now to get red x and red y? Right, to get red x, I add the two x's together. It's why we call it vector component addition. I'm going to put the components that are the same together to get my overall. All right, so that means that red x is going to be 49.59 plus the 86.01. Okay, both of those are positive, so I'm just adding them together. Okay, so 135.6 meters, and that's positive because it's to the right. Okay, to get red y, same thing, except one of my y's is negative. Okay, so I would take my 136.26 and I would add negative 60.22 or just subtract 60.22. Okay, so red y is going to be 76.03. Meters. That's also positive because it still ends up pointing up. Okay, so now I know these two sides of the triangle. I know this is 135.6 and I know this one is 76.03. Everybody all right with what I did there? All right. Can I get C now? Okay. So I'm going to do Pythagorean theorem to get C. Okay, and again, guys, I'm keeping all my decimals. I'm not rounding anything off until the very end. Whoop, I forgot to put a plus sign in there. Let's try that again. That'll work better. Okay, 155.46. Meters. Okay, what am I missing? I need the direction, right? So I got to get the angle. I never even drew that in there, but it's going to be right there. All right, so to get theta, I'm going to use the opposite and adjacent sides. So I'll go tan to the minus 1 of 76.03 over 135.6. So that ends up being 29.28. Degrees, and because we weren't told compass directions here, all I can say is it's above the positive x-axis. All right, I've got the magnitude and direction of my resultants. I just have to put in the correct number of significant digits. Okay. And that looks to be, well, this one's got 3, this one's got 3, this one's got 3, this one's got 2. All right, so my final answer can only have 2. Okay, got to be as accurate as your least accurate number. So final answer is going to be 1.6 times 10 to the 2 meters at 29 degrees above positive x-axis. Okay. Did I do exactly the same steps there as I did in the one previous? I absolutely did. I drew the diagram. I identified all the x's and y's. I calculated all the x's and y's. I added the x's together and the y's together. I did Pythagorean theorem. I did trig, and I wrote my final answer. It's always those steps. Every vector addition problem is the same steps. Okay, draw the picture. Identify your x's and y's. Calculate your x's and y's. Add your x's together. Add your y's together. Do Pythagorean theorem. Do trigonometry, and you're done. It's always, always, always the same steps. Okay? All right. Okay, I want you guys to try number 2. Okay, don't worry about 1. Okay. Actually, no, don't do number 2. Do number 3. I'd rather you did number 2. Okay, I'll give you a few minutes to draw the diagram, then I'll draw the diagram and you can compare. Okay guys, let's just look at the diagram right here. Is scale important here? It absolutely is. Okay, we know that in the first part of this, she goes 300 meters south. And then in the second part, she goes 550 meters. Is that a lot further than 300? Okay. And it's 75 degrees north of east. So here's a reference line that's east. 75 degrees is like that way. Okay? And I probably still haven't done that justice in terms of how long that blue line should be, but it's definitely longer than the 300 meter line. Okay? Almost twice as long. Okay, so this angle here is 75 degrees. This line here is 550 meters. That means this is my resultant. You could draw the triangle reversed if you wanted to, that's fine. Okay. Just check your diagram, make sure it looks at least something like that. The most important thing is that the blue line is longer than the purple line, or the red line, sorry, and goes above the initial position. All right, I'll give you a few more minutes on that one, see how we do here. All right, guys, we'll just kind of start going through the steps here. We've got the diagram drawn, and we've identified our x's and y's. Now we just need to get their values. Okay? There is no red x because it goes, the red vector goes straight south, right? We don't go horizontally at all, so we can just say that red x either doesn't exist or is 0 meters, and that red y would then just be 300 meters south because that's all that goes on in that particular part of the trip. And we would write south. Okay, then we've got to look at our blue triangle. Okay, the blue triangle goes north of east. Okay, I got to find blue x, which is adjacent to the 75-degree angle. So cos of 75 times the hypotenuse, which is 550. Not sine, cos. Cos of 75 times 550. All right, so that side there is 142.35 meters, and that is east, right? And then blue y is opposite the 75-degree angle, so sine of 75 times 550. Okay, so that side is 531.26 meters, and that is north. Again, I'm rounding off on the board, but not in the calculator where it matters. Okay, always make sure you keep all of those decimals. Now I need to get my resultants x and y. My resultants x is pretty easy. We only go east once in this question. and it's in the second vector, right? So blue x and purple x are, they're equal, they're the same. Okay, so purple x then is going to be 142.35 meters east. Y, that's a different story. Okay, purple y is going to be 300 meters south plus 531 meters north. Okay, so when I'm putting all those numbers in, okay, I'm going to get, just so I have all the decimals in my calculator here, I'll take the answer to that there. Whoop. Minus 300, just so I've got the actual number, 231.26 meters north. All right, so now I've got the two sides of this. I know this one's 231, and I know this, whoops, sorry, this one's 231, and this one is 142. Actually, my diagram didn't end up being all that bad, did it? Okay, it's still at least somewhat reflecting. It doesn't have to be 100%, but it is showing that y is bigger than x, so I did okay on that diagram. Okay, so now I need to calculate what the overall displacement is and what the angle is. And since I have the two sides, I can now easily do that. So to get the overall displacement, just Pythagorean theorem, 142 squared with all the decimals, plus 231 squared with all the decimals. Okay, so 271.56 meters, and then to get the angle, okay, if you drew it the other way, which they did here, okay, because they got north of east, so if you drew it the other way, that's the number you got. If you drew it the way I drew it, then you got the complementary angle to this. Okay, it's going to be tan to the minus 1 for the way I drew it of 142 over 231. All right, so I'm getting 32 degrees, 31.6 degrees, and for me that is east of north. Okay, now we just have to put in the right number of significant digits. They do this wrong. Okay, your vector is a measured value and should have the same number of significant digits as your magnitude. Okay, so our final answer here to 3 significant digits is going to be 272 meters at 31.6 degrees east of north, or at 58.4 degrees north of east. Okay, everybody with me there? I wouldn't give you one harder than that on a unit exam. Okay, usually what I do on a unit exam is I give you one vector that's straight, like due east or south or whatever, and one that's angled, because it doesn't take you as much time, but you can still demonstrate to me that you know how to do it. Okay, rather than give you 2 angled ones and then that takes an extra, 5 minutes or whatever. It's just not worth it. Okay, we're going to do harder ones than this for sure, ones with more vectors, but on a test where time's a factor, okay, that would be more like what I would ask. All right, is this making some sense? Right, we've only done displacement vectors so far, but this is how you would do a net force calculation in Unit 2. Okay, when we get to Unit 2 and we have to add 2 forces together, so let's say 2 people are pushing on a desk. Okay, one's pushing due south and the other's pushing south of east. The chair is going to move that direction, right? So it'll be the same thing. It's just you put them tail to head and you do the vector calculations just like this. It's just at the end, instead of being meters, it'll be newtons. Okay, or if it's velocity vectors, it'll be meters per second. The method is what's important, and it is the same no matter what vector quantity you're doing this for. All right. Okay, how are we feeling about that? Okay, reminder, I can't remember if it was you or period 4, I forgot to tell. you do not have a quiz tomorrow. Okay, no quiz tomorrow. We just haven't gone through enough stuff to bother quizzing you on. So next week on Friday, you definitely will have one. Okay, probably be mostly this stuff. But that's what we're gonna be working on tomorrow, next week, okay, that kind of thing. By the way, we also have Monday off, don't forget that. Okay, short week next week. PD day, you have it off, I don't. Actually, you get a day off and not me. All right, since we don't really have time to do another one, okay, we'll leave it there for today, okay?